All right, here we are doing number 7. Let's just take a look at this. So we got a 10-kilogram object. Let's just calculate a couple things. And we're moving at constant velocity. So this tells us the force is balanced. So let's just get the force of gravity, which is the weight. That's going to be 10 times 9.8. So that's going to give us 98 newtons here. But notice the normal force balances the gravity force because we don't sink into the floor or get thrown up into the air accelerating. Now, let's see. The applied friction force is 0.2, but we're sliding at constant velocity. So let's get the friction force, which is mu times n. That's going to be 0.2 times 9.8, and that should be, I believe, 1.96. Yep, 1.96 newtons of friction force. And that tells us the applied force to balance it out also has to be 1.96 newtons. Now, what this tells us is, another way of saying that the forces are balanced is that the net force, the total force, the sum of all these forces acting on the system, is a big, fat 0. Alright, now for number 8. We have a 50-kilogram girl. She's wearing metal ice skates and standing at rest. Her boyfriend comes from behind and gives her a push. How hard must push be to get her moving? So we need steel and ice's coefficient of friction. We need the static friction, and we want to know the maximum push possible. So let's do the free body diagram. I have the normal, I have the weight, I have the force of pushing, and I have the friction force. And so I know that the weight is going to be 50 times 9.8, which is 490 newtons. And what that tells me is that the normal force is also 490 newtons. So to get the pushing force, that actually has to equal the friction force, the maximum friction force to get her moving, and that's going to be mu static times the normal force, which is going to be 0.03 times 490. We're talking around 5 newtons. Let's just get the exact number. We're getting, 15 newtons of force. So 14.7 newtons of force. Now, for problem number 9, let's just take a look here. She's sailing on the ice. How hard does he have to pull to keep her moving at a constant speed? So what you want to do is you want to multiply by 0.05. So I'll get you set up. That's going to be mu kinetic times the normal force. Now, the funny thing is, the answer to 9 and 10 should be the same. And I want you guys to go ahead and actually try to get this now. Talk to somebody next to you. Solve the problem. This is very likely to be something that I'm going to quiz on next week. So I don't want to give it away, and I don't necessarily want to confirm your answer. So talk with each other now.